Hola, mathletes. So this is our last lesson that we're going to do in chapter 4, transformations of quadratics. And this is actually somewhat of a review from something we did earlier this year. So we talked about transformations before, right? Transformations of functions. We talked about this being the general form where this is the function, right? And the function could be some operator, right? Like it could be a square root. It could be an exponent like a square here, or a cube, or it could be absolute value. A lot of different things, right? The main ones that we talked about were constant, linear, absolute value, and quadratic. So we've actually done this before. And so we know with a quadratic, let me see, missed the K there. It looks specifically like this, right? Where remember that whatever's out here is a vertical stretch or compression, or vertical dilation. Whatever's in here is a horizontal dilation. It's backwards. So like multiplying by something bigger than one actually horizontally compresses it, whereas you think it would make it bigger. All right. And then H moves it left or right, and it's opposite. So when it's minus H like that, it'll actually move it to the right. When it's plus H, it'll move it to the left. And then K moves it up or down, right? That's a vertical translation lever, right? So it moves it up and down. All right, now what we can do is we can actually simplify that. And instead of putting the B here, we can actually just factor out the B and just keep it with where we just have a value for A. All right. So B and A are not equivalent, but yeah, it's just something that we can address, make it to where there's no coefficient in front of X. We can just bring it out to the front here. Okay. All right. So let's be more, or let me write these down. So remember, A is causes a vertical stretch or compression. Stretch. And that's if A is greater than 1, or compression if A is less than 1. Okay. And also, it tells you the direction of opening, right? If A is positive A, means it opens up. And negative A means it opens down. Right, and also tells you max or min, right? Opens up means there's a min, and opens up means there's a max. Open down means there's a max, sorry. All right. Okay. So now the H, negative H moves right, and positive H moves left. Okay. And then with K, positive K moves up, and negative K moves down. All right, so those are our transformation levers. And so we know that our parent function starts right on the origin, right? Goes like that. So it goes through the origin at 0, 0. That's where the vertex is. And then we have a point at 1, 1. Right, and then 2, 4. Right, and on this side it's at negative 1, 1, and negative 2, 4. All right, so anyway, remember that, just remember, what all those different things mean. So what we're going to need to do is we're going to be given equations sometimes in standard form, and we want to get them to be this form right here, and we call that vertex form. Okay, and the reason we call it vertex form is because the HK is the vertex, right? So just by looking at it in this format, you can actually just see H and K, right? The thing with H is don't forget to get the opposite, right? So like if you have minus H here, then H is going to be positive here. If this is positive here, then H will be negative down here. And then K, whatever sign K is, that just comes down. All right. So this is vertex form. All right, and here's the definition here of vertex form, right? And then the other thing I forgot is x equals h is the axis of symmetry, right? And then it says, like we talked about, A determines the shape, like the how wide or narrow it is, and then the direction of the parabola.